Okay, so this is 8.3. We're going to be talking about sine waves, but before we get into that, I want to make sure that we understand what the difference is between sine and cosine, because they're really not much different. So if you look at this triangle is, we're going to call this angle theta. What I want you to think about is, what would this angle be? Okay, so first of all, here's how I want to look at it. If I label this triangle as A, B, and C, if I want the sine of theta, that would be equal to A over C. Now, if you think about this angle down here, okay, this angle down here, if we were going to take the cosine of this angle down here, hopefully you understand that the cosine of that angle, whatever we call it, would also be A over C. So the sine of one angle will always be equal to the cosine of the other angle. Now let's think about, how would we find what this angle is? Well, I know that these two angles have to add up to be 90 degrees. So this angle would be 90 minus theta. So if you think about it, a sine and cosine will be equal to each other as long as the cosine or vice versa is 90 minus theta. So let's kind of take that into what our next slide is and kind of show how this works out. So if you look at this, what you're seeing here is it's saying that the sine of theta will be equal to the cosine of pi over 2 minus theta. Remember, pi over 2 is the same thing as 90. So 90 minus theta, it's the exact same thing. So that's when a sine and a cosine graph will be exactly the same. That's why we kind of call both of them sine waves. We don't say, oh, this is a sine wave and this is a cosine wave. We just call them all sine waves because we can make them all be equal to each other. So now if you recall, in the last section we started talking about amplitude. So that was where we would stretch out our sine curves. And then we also were talking about our periods. So that's where we would kind of scrunch them together or spread them out. Well, we're going to move a little bit further on this. And here is what our general form of a sine function will be. It's going to be y minus k equals a, we did that yesterday, sine of b, we did that yesterday, and then on the inside here it's going to be x minus, sorry, not plus, minus h. Now, the only thing that's different is the k and the h today. And what that is that is going to move our sine curve vertically, like shift the entire thing vertically, up or down. And then the h is going to move it left or right. So moving it left or right is actually what helps us to make a sine curve look exactly like a cosine curve. Okay? So this translates the function y equals a sine of bx, h units up, I'm sorry, h units right, not up, very important, h units right, and k units up. So in other words, if k is negative, it will move it down. If h is negative, it will move it to the left. So it can go the opposite direction depending on whether it's a positive or a negative. Okay? So this is the same way that any other function is translated that we've learned over the years. Okay? So a couple more formulas that I want you to see. We have amplitude. So we talked about if amplitude, this is more if you're not given an equation. So the amplitude will always be figured out by wherever the y value is, okay, so the max value minus the min value, and then dividing it by 2. The period, or the b, the frequency, the b of the equation will always be 2 pi divided by the period. So remember, period is how long it takes to get from the start of a point to the next part. So maybe you're going to use the peak. Maybe you're going to use the highest point on the sine curve. How long does it take to get from one high point to the next high point? That's the period. So doing 2 pi divided by that will give us what our b is. And the axis will be the middle of it. So if you were to draw a horizontal line through the middle of the curve, that would be the axis, so that way it divides it completely in half. and we do that by getting the max value plus the minimum value dividing by 2. That will tell us where the axis is on the curve. Okay? So what I want to do is I want to look at, we're going to flip this paper over. So now you're looking at this curve right here, and it's really small on your paper. So I want to blow it up a little bit on my computer here. So I'm going to blow it up on the computer. I'm going to pause the video real quick, and when I come back, we'll have something else on here. So, okay, so this is kind of a blown up graph here. So what I want you to do is I want you to notice that what we have here is we have this blown up graph, and what I'm doing is I'm basically telling you that in between the high points on your graph that you see on your paper there, that is 4 pi. So what that does is that tells us that our period is equal to 4 pi. Okay, the other thing we can figure out is we can figure out our amplitude. So our amplitude here, if you count this up, 6, 7, 8. So we're at 8. So our amplitude is going to be 8 minus, and down here is a -6. So 8 minus a -6 divided by 2, and that is equal to 7. So our amplitude is equal to 7. Okay, our axis is going to be equal to 8 plus a -6 divided by 2. So that's going to be equal to 1. So that means that our axis actually goes across right here. Okay, so now the only thing we really need to figure out from here is we just need to figure out where is the axis going to go. Okay, or how did it shift? How did our graph actually shift? So I can tell you this for a fact. Now it's hard to tell on your graph, but I'm just going to tell you this to help us out. In between here and here, that is equal to 3 pi over 2. Okay, so basically what you want to look at is you want to notice, first of all, that the graph shifted up. The graph is shifted up because that's where our axis is. So that means that wherever our axis is, that is what our k is equal to. So our k is equal to 1. Now we just need to figure out what our h is equal to. Well, our h, again, what you want to do is you want to find a point on the graph that you know of for sure. So for example, if we were to shift this back down to where it was originally supposed to be, then you would want to know how far it gets back to the beginning, because we know that this point right here, okay, would be normally right here, okay, because we shifted it all the way to the right, 3 pi over 2, and we shifted it up 1. So if we bring that down, I'm telling you right now that between here and here is 3 pi over 2. So that is what our shift is. Sometimes it'll be easy to see on a graph. Sometimes it'll just be a simple, 2 points left, 2 points right, things like that. But I'm giving this to you, so it's 3 pi over 2. So now we have all this information. We can use the period to figure out what our b is. Our b will be equal to 2 pi divided by 4 pi, which actually the pi's cancel out, and that's equal to 1/2. So now that we have all of our values, we can now write an equation. It's going to look like this. Y minus 1, because that's what our k value is, equals 7, because that's what our amplitude is, sine of 1/2, that's our b, and in parentheses it would be x minus 3 pi over 2. Okay, so here's what I want to do. I want to leave the video here. We're going to stop it here. The other one, see if you can do that one on your own. If you can't, this is the first thing that we will do when you come into class. So do that. Again, don't forget to take your Edmodo quiz if that's been assigned. But other than that, I hope this made sense, and I'll see you in class.